Good evening, everybody. We'll get things kicked off. And for folks in the room, I've unmiked the whole room. So if you find yourselves having a chat in the back, be aware it might not be a private chat anymore. Right? So FYI. All right. Okay. So, all right. A warm welcome. My name's Adam Hems. I'm the leader of the Houston Azure Group. I've been running this since 2016 or thereabouts. So who's a lot of familiar faces, actually. I think almost everyone. Has anyone not been here before? Brad's first time? Okay, I happen to know Brad. Bernard?
Been here before.
You've been here before?
Yeah.
Okay, it's been a little while. All right, but
Few
okay,
months,
okay,
yes.
okay. Welcome back, and welcome, Brad. So the focus of this group that we try and meet monthly is about learning from one another, learning about technology, about the way it can be used, the problems it solves. Because here in Houston, we have a lot of different industries represented, obviously a lot of oil and gas, a lot of healthcare, a lot of some finance, in fact, but the problems for each tend to vary by industry, but the technology used to solve them can be the same. And so there's not really a good place where people using the same technology, in this case Azure, can come together and learn from each other, because the stories are very similar. In my day job, is as a cloud architect at Microsoft. I've been doing this since 2016. Microsoft for 15 years now, but this role focused on cloud since 2016. And I've been doing cloud since 2007. I have an AWS account, which I got in 2007. I still have it. And I was at the launch of Azure in 2010. And so I've seen a lot of cloud journeys. I've been doing this cloud full time since around 2013. Like I say, they're very similar, even though I work individually with different folks, different teams, different technologies, different companies. So much is so similar. But there's in my day job, we're all under NDA, can't share what we're doing, things like that. But the intention of this is a place where folks can just informally, in your own time, right, just learn from one another, share experiences as you feel appropriate. It's just a place to come together and share some of the pain, learning, sufferings, that kind of thing. So we cover a bunch of different areas of focus. Anything generally speaking, Azure is what we like to talk about. And today we have one of actually my personal favorite technologies. I have a weakness for the container-based technologies, happen to like those. So I spend a lot of time doing those with my customers. Happens to be a depth of expertise that I happen to have, so I like it. I've done some other presentations on some of the container technologies we have in Azure, and I've worked with a number of customers on this particular technology, actually, Azure Red Hat OpenShift. So this is a good one. I was very pleased when the Red Hat guys here reached out and said, "Hey, can we talk about Red Hat with you guys?" And said, "Oh yeah, that sounds great," because it's one of those technologies. There's a lot to it, and so this is a good forum for learning about it. The mics are on in the room, and also folks online. I see some folks coming in now. You're welcome to come off mute if you have questions, and interrupt in the room with questions as well. The intention here is this is a discussion, area of learning. So it's informal. With that, I'll introduce the Red Hat guys, but before I do so, I want to thank them because they're feeding us tonight. So the food tonight is courtesy of Red Hat, so thank you. And we would be doing this earlier or doing it virtually if we did not have that. So that's
The virtual pizza is singularly unsatisfying.
Virtual, yes, that's right. Or bring your own, right? Yeah, that's it. Yes, indeed. Thank you, Ray. All right, so with that, I'll hand over to Stephen, our presenter, and Thomas. But yeah, go for it, Stephen. Take over presenting, and everyone should hear you on the overhead mics.
Okay.
Let us know if you can't hear Stephen. I went for the mic, but
how does the audio sound?
Audio sound good? Can y'all hear me?
Yep.
Hello, everybody.
Yes, we can hear you.
Awesome.
There we go.
Here we go. Voice,
The technology is working.
the voice of the sky.
Yeah.
All right. Okay, so first off, we'll do some introductions, point out some of the Red Hatters in the room. So, this is Thomas Hall. Thomas is one of our tigers. He's a specialist who goes around and does some really, really cool stuff at a bunch of different customers. He's got a lot of expertise, so if you grab him afterwards, he can get you pointed in the right direction. Frank Smith is in the back. He's one of my fellow solution architects. He just stayed. And then Keith Arwin's in the back. He's our solution architecture manager for the energy pod in Houston. So make sure if you have any questions or anything else, if you don't feel comfortable speaking in front of the group or anything else, we'll be hanging out afterwards. So you can come and ask your questions, and we can talk ad nauseum about this stuff. So to kind of kick us off, I also want to introduce myself. So my name is Steven Emo. I am a staff specialist solution architect with the Energy Pod in Houston. So I am the dev of the DevOps group. So I actually have a development experience background. Woohoo! Yes. Who are my devs out there? Anybody that's a pure dev kind of folk?
Dan's a dev, his hands and very high, but
All right. So who's my infrastructure people? Who's my ops people? There we go. So yeah, Thomas is we're the yin and the yang here for the dev to the ops. So the Venn diagram works pretty well. So I've been doing software development for a really long time. Java, .NET, Python, all of that other stuff. I was in consulting for a decade. I push coded a dozen different Fortune 100 companies, and most of them energy trading companies or equities trading companies. Done some really cool work in the energy trading space, but I've also done like low latency trading infrastructure for JP Morgan, where we were having fun down in the microsecond level type of stuff. So really, really kind of fun experience it's so far, right? And that's really about it. I've done agile coaching in the past and stuff like that, so I can kind of talk to anything related to this and Kubernetes and Red Hat or anything else. So, you know, guys, see anything on here that you want to talk about afterwards? Here, good to go. So, so I always want to kick us off with a little bit of understanding, because I always like to talk about Red Hat. Red Hatters always like to talk about Red Hat because Red Hat's a really unique company. Our story is unique. We are the first $3 billion open source company. Some might say we're the only really, truly natively organic open source company. We were open source from the start. If anything, I feel like Red Hat was the company that defined the open source model for the entire ecosystem. We're very oriented in that, but I think it's justified. I think we've done a really good job with that. Right, we got a 90% of Fortune 500 companies. Everybody knows Red Hat Enterprise Linux, right? That's kind of our go-to. RHEL is awesome. It's used everywhere. It's ubiquitous. But we're the world's leading provider of open source. The little footnote at the bottom is always fun too, right? We are a wholly owned subsidiary of IBM. We are separate from IBM, however, right? So we still run our own thing. But the interesting piece about this is IBM bought us back in 2019 or 2018 or whatever for $34 billion. We don't own any IP. We're an open source company. All of our stuff is community led. We do not own any software. It's all open source. So they paid $35 billion for what? The people and the processes and the expertise, right, from the company, right? So that's where we're at, and that's really kind of coming from the open source community, right? It's all of these projects. It's this huge swath of developers that can all contribute to a single common goal. And what we do is really kind of take it that next step, take it to the goal line, right? And we make it available for enterprises to be able to consume safely. We provide support for all of those things, and we contribute a ton back into those projects. Some of the funny kind of stories I like to tell people is like some of the open source projects that are built into OpenShift or built into RHEL or whatever. Like if a customer wants to talk to somebody about like something like Prometheus or Grafana or whatever, I can usually reach and touch somebody that's a core contributor on those open source projects that is a Red Hatter, right? That's what they do for a living, right? So it's really, really neat. It's a neat company to work for because I can kind of reach out and touch some of the engineering gods out there. Some of those people that are just like, wow to work with because they are contributors and founders of a lot of the open source technologies projects that we build into ultimately Red Hat deliverable projects. So diving right into that, we're about community, right? So from a Kubernetes standpoint, because when we start talking about Red Hat OpenShift, we're talking about Kubernetes, right? This is one of the things that we also like to show off is like, we're in this in the open source, in the community, right? We are in the leadership of all of these different working groups, steering committees within the open source community. This is not something that is proprietary or anything else. We are out in the community, both creating and contributing to these communities, right? So it's not about, ultimately we're a business, not everything else, but we are really focused on community more than anything else. And when you start looking at our participation and leadership in open source projects, right? If you look at the CNCF, like we're in all of these things, right? So it's not about taking open source projects and then just not contributing back to it. Everything that we bring in as a company, we're also contributing just as much back out to the community as we take it. So it's a partnership. It's a vibrant partnership between the community and Red Hat. Same thing for the Linux projects, right? If you look at all the Linux projects, right? We're in it from the upstream standpoint. So when we talk about upstream, that goes to the open source projects. It's the upstream. And that's kind of one of the things that's really kind of neat about this is like we just passed. So our OpenShift product just passed $1 billion annual recurring revenue, right? That's a lot. And that's just OpenShift, right? We're not even talking about RHEL or anything else. This is just our OpenShift Kubernetes platform, right? That's great. And people wonder how we do it, right? And it's about community, right? What are we doing that's different? And this, the guy, Adam Jacob, he was one of the founders of Chef, right? So he's a kind of a famous guy, right? But like he articulated very well from a third party, right? What we kind of do that's different and what sets us apart. So when we start talking about the value of OpenShift, before we get started on this, I want to make sure that we're reading the room correctly. I just want to get a hand. Who knows Kubernetes? Does anybody want to go over a quick 5-minute reminder of what Kubernetes is?
I think that'd be a good idea. Just a level set.
Walking into sometimes it's different rooms have different expertise, so that's great. Kind of go through this at the core concept level, and then go.
I think John, did you have a question? I muted you though.
Oh no, I just raised my hand in saying that I know Kubernetes.
Okay, thank you.
Yeah, we won't take this. We can talk about this afterwards if anybody has any questions. But so I'm not talking about just talking about Kubernetes now, right? So what we're talking about is containers, right? And what is a container? A container is something that runs in an isolated piece of the system, right? It's supposed to be, it's a packaged piece of runtime executable that is sandboxed within a Linux kernel, right? So it's something that is supposed to be the smallest kind of unit of compute as it relates to anything else, right? And containers are created from images, right? So if we're familiar with the container file, right, we can extend the Linux kernel, we can add in our packages, we can create these images, and these images are statically composed, immutable objects that give us the ability to really define and create a runtime, for the container in a pure definition. When we create those images, we store those in a registry, right? So when we go to start our container, we reference the image that's stored in a registry. So our registry has just an address. So this image is at this address, right? And so when you start talking about images also have versions, right? So for each one of these, if you create an image for your front end application, right, it'll have different versions as you create different images, and you're creating and compiling your software, putting it into the image, and then there's, also vendor stuff, right? So like different databases and things like that can go into their images. But at the end of the day, the containers run in these things called pods, right? So some people kind of get this confused about Kubernetes. They think it's actually, the container does not run. It always runs inside of a pod. And the pod is kind of the compute that goes around it. If you could have more than one container inside of a pod, I always think about a pod as that's your local host. So if these two containers in this pod want to talk to each other, they can talk to each other as if they're local host, as if they're,
And you could put Docker containers inside your pod.
Yes, so containers are, Docker is one way to execute containers. It's evolved now to where it's actually, there's multiple runtimes that can all execute container images. So it's all been abstracted now to an open source spec in which Docker contributes and implements. So when we start talking about Kubernetes, what we're talking about is the replication capabilities of it, right? So I can, on a Linux box, I can start a container, I can stop a container. But what Kubernetes starts to do is orchestrate these things. Is I want to run these containers, or I want to run this many pods, or I want to start doing. So we're starting to define the runtime of what we're wanting to do in terms of running containers, right? And that's where these replica sets and replica controllers start to come in. That's where they start defining what the image that we want to use. How many of them do we want to run? How much CPU do we need to use? How much memory do we need to use? What kind of storage needs to be provided to it? It's just some of those level abstracts that kind of come into play.
Yeah, and there are Windows containers. You're just very familiar with the Linux side, so you'll hear us reference that a lot, but there are also plenty of Windows containers out there as well.
Yes.
So.
Deployments and deployment configurations actually can define the way you roll those pods out in your Kubernetes cluster, right? So again, you can tell it, what the images is with how many replicas, what the strategy is for rolling it out. So you can have it to where a new version can roll out piecemeal, right? One at a time, to where there's no downtime. There's other strategies to where you can bring the whole thing down and then spin the whole thing back up. So there's a bunch of different optionality there. A daemon set actually runs on every single node. We're going to skip that for now. But at the end of the day, there's a lot of different aspects to Kubernetes where it's all manifest based. So it's all based in YAML or JSON, and it's actually going back. The best way to describe it is actually a Microsoft concept. Was the desired state configuration that was back in the day. What Kubernetes does is it takes manifests described in JSON or YAML, and it runs a reconciliation loop to make sure that the pods that are running on the nodes are created the way that we're expecting them to be based on the configurations. So if I create a new manifest, the reconciliation loop goes, oh, look, there's something new. I need to go create it. If something dies, the reconciliation loop goes, oh, wait, there's supposed to be 4 of those. I only have 3. I need to create another. So it's just kind of doing this loop back and forth. And so the way you do your configurations with that is you do things like config maps. So you can put all your configurations in a config map, and then you can attach the config map to your deployment configuration. And there's a lot of stuff there. So secrets are a different way. I'm going through this really, really fast. We will dive deeper into this as we see OpenShift. So, but from a core concept standpoint, that's really about it. So questions so far? I've gone through a lot real quick on that. Is there any questions so far? Did I lose anybody? This is complicated stuff. Like Kubernetes is not like, this is not easy. This can be complex to some people. So
Got one. Is there any way you can mic yourself a little bit better? Because when you're near the computer, I start to hear hear you coming through the speakers. Where you are now, I don't hear you coming through the speakers. I just hear you from you.
He's not coming through the speakers.
Hmm?
He's not coming through the speakers.
it might just be the echo of like where I'm at with this.
Yeah.
Okay, I'm sorry to interrupt.
Oh, you're right. Can you guys hear at the back? Okay.
So I have all these pods that are running now. Okay, that's cool. Well, I want to talk to them. So if I have a web service that's running out there or something like that, how do I get to them? So that's where this service concept comes in. Is a service is a description of the logical place of like where my pods are running, right? So when you define a service, your pods, when they come up, they'll actually tell the service, hey, I'm up. And the service will recognize that they're up, and then we'll actually start like load balancing traffic to it, right? That's the best equation for a service. It's kind of a load balancer. It's a service locator, right, for where the pod is ultimately running. And then,
Everything is DNS based,
Yeah.
so you will call your services by name. You really don't ever have to worry about IP addresses ever again because you're required to use DNS naming. So it makes it easier whenever you name your service, it has to be a DNS compatible name, and then you just call it that way.
So apps talk to each other via the services. You never talk pod to pod because IPs are constantly changing. And then routes or ingress from a raw Kubernetes standpoint gives you the ability to kind of come in from the outside, right? So services are inside. You can talk to services inside the cluster. If somebody wants to talk from outside the cluster to the cluster, you have to have either a ingress or a route or something like that, which basically just points to the service. It says, if the URL says this, then shove it over there. With that, there's also storage, right? So if you need storage, that's actually abstracted away really, really nicely to an app developer. There's these things called storage classes and persistent volume claims where I could actually just say, I need 10 gigs of medium storage. And however the administrator defined it, it'll mount it to the pod, and it shows up just like a mounted drive or whatever. So it's really easy to manage.
Is that the same view of storage? Like, let's say if you have a horizontally scaled app, or you've got, like a web server, and you've got 2 instances of the web server, do they get the same view of like a single storage, or do they each have like a separate volume that, like, if one of them writes over here, does the other one read the same thing, or are those like separate?
It'll depend on the application. There's different kinds of storage. There's read write once, which is like your block type storage, right? Where they would be writing to individual, like they would be writing to separate storage devices. Applications like caching or something will use that, but they also have shared storage, which is read write many, where they can share the same and read and write to it. It just depends on what type of storage you're using and what the application needs from a storage standpoint. Because when you have multiple writing in the same place, that can cause corruption. So it really depends on what application the storage require, I mean, the storage requirements are for the application. But you can pretty much fit any box, right? Because there's read-only storage. If you need a bunch of places, pods to read from one place, they can. So.
And you put all that in like the deployment YAML or?
Yeah, so when you, the great thing is from a developer standpoint, you can just say, hey, I need shared storage. And then it'll give you shared storage. Or, hey, I need, just block storage. Okay, I've got it, right?
Okay.
It's from a developer standpoint, it's a lot easier to use than like, oh, what replication is this? This is replica 3. What are the IOPS? What's the throughput? You basically just, pick what storage you want and then it just automatically gives it to you. So,
Cool, thanks.
which is configured by the admins, but from a developer, it's pretty easy to consume.
Yeah, life is easy.
So is that like the philosophy? Because it seems like from like a sysadmin standpoint, it's super complicated. But it sounds like from the developer standpoint, it's designed to be like easier and less.
Correct. Yeah.
Okay.
Yes, that's correct.
Isn't that everything?
It should be easy for the developers, right?
As a lazy developer, yes, I resemble that remark.
As an ops person, our goal is to make the developers be able to develop and not waste their time asking administrators questions, submitting tickets or anything like that. So Kubernetes, one of the reasons why it's so popular is it obfuscates that from developers, right? A lot of these things and a lot of it's programmable, right? You write it in code. You don't have to click buttons or it's very declarative, right? You say, I want to do this and it just does it for you. So
What do you think of the school of thought of clusters should be stateless? I know we were just talking about it can give you state in the cluster if you want. What are your thoughts on? Well, don't do that. Get your state from something outside of the cluster, whatever is appropriate. I've seen that.
What do you want?
I'm a very stateless kind of person.
Okay.
Like if you're using a lot of disk, I have some questions.
Right. That's exactly what I've seen a lot of.
Yeah, originally Kubernetes didn't even have storage. It was just all ephemeral, right?
Right.
Everything was designed to be just,
Right.
if it's gone, it's gone, right? And then we eventually added in new features, and now we have storage. So,
Yeah. I guess what I was saying is maybe it might be better to not use that.
Yeah.
Just,
There's that's a very controversial subject.
right.
Is do you run databases in Kubernetes?
Or cache stores
Yep.
or anything, any kind of state, whatever it is, whatever your state is for your app, should that be on Kubernetes or should be on something else?
If there's an in-memory data grid, I'll argue that that's a perfect case for Kubernetes, right? So it's
Yeah.
depending on what the persistence looks like. And it depends on what kind of persistence. If talking about a relational database, that's one thing.
Right.
Talking about Cassandra, that's something else.
Yeah.
Talking about Cockroach, that's a completely different, right?
Or
It's almost as,
just files, just blobs,
or blobs.
some seismic or something.
Yeah.
So this is where you get into containers and virtual machines running side by side to support your applications because
Yeah,
depending,
stuff outside of the cluster.
and I don't know if you're going to touch on that, but we do have capabilities around with.
If we have time, we'll talk about this.
All right, anyway, I didn't want to derail this, I just thought that's, like I say, it's a controversial,
It is.
yeah.
So one of the interesting pieces of this is liveness and readiness probes. Most of the time, people just kind of skip over this. This is actually one of the most important parts of Kubernetes. Because that reconciliation loop that's running, where it's looking at the manifest and then it's looking at what's running, how does it know what's running? Liveness and readiness probes. So the system has to be able to detect when something is down for you to be able to reconcile that something is down and take remediation, right, to fix that, right? So if you don't have liveness and readiness probes open on your applications, you're gonna have a bad time.
I've seen this one trip up, the lazy developers like me can't be bothered. You actually do have to write those probes. Your code has to do that for the infrastructure to leverage it.
It's one of the very first things that I mentioned to customers is you should put in a mutating or what's the other type of webhook? Not the mutating, the validation webhook. into the ingress or into the Kubernetes API controller to say, if a deployment comes in and it doesn't have a readiness or liveness probe, just deny it.
Yeah,
Like-
right, right.
Like, that's the very first thing that I usually tell customers, like, you need to put that and request limits for the size of your. That's also another,
You mean admission controller?
yes,
Okay.
admission controller, that's it. So the projects can also be isolated, right? So this is the kind of neat thing is like with all the namespaces, so a namespace kind of is that logical unit of things that are started and put into a namespace. You can have really tight controls between the namespaces. So you can, with the proper controls in place, kind of run multi-tenant type of scenarios and have very discrete controls for network and all that stuff between the different services.
Think of it like a resource group in Azure, right? It's a logical grouping of objects. So
Okay, pausing for a second. Thoughts, comments, questions?
Done silence.
All right, that's great because it just gets more fun than there. Because Kubernetes is just the start. Like all Kubernetes does is pod orchestration. At the end of the day, that's all it does is it spins up containers and pods and attaches storage to them, and then it creates some networking stuff around it. Everything else is not included. Authentication, none. Automation, security, any kind of secondary network controls, storage, registry, logging, monitoring, all that stuff has to come from something else, right? So it's when people look at Kubernetes, Kubernetes is just like the baseline. I almost look at it as like Linux, right? Or Windows, right? It's like, that's just the start, right? It's everything that you now have to put on top of that. Right, so what OpenShift really is built for is for those people who want to take an opinionated view of a best of breed set of things that combine together to create an enterprise level Kubernetes experience, right? So with OpenShift comes all of the things that we were listing off. So if you need monitoring, there's tools for monitoring that are already built into it. For logging, it's already built into it. For GitOps, it's already built into it. Service Mesh is already built into it. And it's all supported and designed to work together seamlessly. So you're not having to build a Frankenstein of 10, 15 different open source projects, all with different release cycles, all with different support mechanisms. We bring them all together, we test them, we harden them, and we make them really, really easy to consume, which I'll show you from a demo standpoint later on. It's the easy button, right, when it comes down to.
are you going to talk about ARO at some point?
Yes.
Okay. Just make sure.
Yeah.
Oh, never mind.
Okay. So how do you run OpenShift?
Nice segue.
Yes. So how do you run OpenShift on Azure? Right, there's a couple different ways. One of them is kind of that self-managed kind of thing. At the end of the day, it runs on computers. So if you have some computers, if you have some VMs, you can actually go and deploy and manage all of this yourself. There's some, but the real way to do this is actually with Azure or Red Hat OpenShift, right? So ARO. And what ARO is, right, is it's a jointly delivered managed service between Red Hat and Microsoft, right? There are SREs that are on staff from both organizations helping to deliver and manage the service for you, right? So it's not something that is, it's just Red Hat and Microsoft isn't involved, or it's not just Microsoft, it's both of us together helping to deliver the value, right? So if you have an issue, if it's a Red Hat issue, we help with that. If it's an infrastructure issue, Microsoft's ready to step in and help with that. But they basically give you that SRE experience with the 24/7 support, lots of SLAs, You know, and it's a native service that goes along with it. So, and we'll get to the demo here pretty quick because I'm tired of talking about slides. But the two other key kind of factors here is it's a native service. So we'll show you, we'll go into the Azure portal and you'll be able to see it's just like any other service that you would consume on Azure. You can click it and get started with it, right? And it goes against your hybrid committed spend or any kind of agreements that you have. It's just like any other service that you would obtain via Azure and consume. So it goes against if you have existing contracts or hybrid committed spend or anything else. It's just like consuming anything else, right? So so that's very helpful for those of us that are in that have those contracts. This is kind of you speak to hybrid environments span. Sorry, what was that question?
McKenna, do you want to just speak that out?
Yeah, so we have requirements wherein we do OpenShift on-premise with Arrow, AKS, EKS, GKE in one environment within a large corporate. Can you speak to how this would work across multiple, on-prem coupled with Arrow coupled with AKS?
So yeah, so AKS is a different service. It's not OpenShift. AKS is there any AKS?
Yes.
Okay.
What do you need? It's Kubernetes as a service, and that's it.
Yeah. So think control plane.
Yeah.
Worker nodes.
Yeah.
That little green box that we showed earlier.
Head nodes are automated, but that's it. It's just plain vanilla Kubernetes. Good luck.
So the hybrid story from a Red Hat perspective is OpenShift don't care where you run it. Like, so we can run on-prem, we can run on any hardware, we can run on bare metal, we can run on VMware, virtualization, we can run in the cloud, any cloud. I think almost every cloud now, like we're getting to like Alibaba and all of those now too, right? We have managed services across all the major clouds, all of the other things. But the way that we look at it is from an OpenShift perspective, quite literally, the only difference between running on-prem and in Azure, the only difference is the machine configurations, because obviously Azure uses Azure VMs and all that other stuff. And on-prem, you would use your on-prem hardware or whatever, and storage, right? Now, there are some other things, like there's some implementation details around like ingress and things like that we may use some native services when we're in the cloud.
Yeah, Azure load balancers, for example, and only specific virtual machine sizes in Azure for Arrow, just the supported ones.
Yeah, I mean, because that's the smartest and easiest way to do it, right? But at the end of the day, it's abstracted away from the actual OpenShift user, right? To the abstract to the user, it's all ingress. It doesn't matter how it's implemented. I don't care. I'm a developer. I don't care. Now the administrators, they do. Right? They got to get in and configure out and make sure. But we make it easy.
I mean, the best thing is really that whatever infrastructure you are, when you're migrating to Azure, it's the same experience, right? If you were on bare metal or another cloud going to Azure, it's the same portal. From a developer standpoint, you can do the same thing. So it just makes it a lot easier, that transition.
We play nice with everything, right? So that's the great thing about OpenShift and Red Hat in general is we tend to be Switzerland, and we tend to work with everybody. And Azure tools and management developer and management tools are no different, right? So we can integrate with all of these things. You can use some of the things out of the box with OpenShift. You can choose not to use some certain things out of the box with OpenShift and say, I want to use this other thing. And as long as that other thing supports Kubernetes in a native way, we don't care, right? That's the kind of the neat thing is it gives you that optionality. And this kind of speaks to a little bit about kind of running your own cluster versus the managed service, right? So if you're running your own OpenShift cluster, you got to kind of do all this stuff. We have installer tools. We have like some automated installer tools that help you with all of this. But at the end of the day, this is kind of everything that you need to kind of support. We will support the platform, Microsoft will support the infrastructure, but if you're running your cluster on your own, then you got to take care of all this other stuff. We're talking about today is this, ARM, right? We got you. We got all of that other stuff in between Microsoft and Red Hat. We're managing all your clusters, securing the nodes, monitoring everything. And as a consumer, you're worried about application lifecycle and user management and all those other things. I've already said all of these things. So we have tons. So like, as I said before, it's kind of this, it brings it all together, right? So it's, if you want to run serverless, it's Knative. Like, it's not some weird proprietary thing. It's the largest open source, project from a CNCF standpoint that's for serverless technology. Our pipelines are Tekton, which is one of the largest CNCF projects that's actually a spinoff of Knative. Our service mesh is implemented in Istio, right? There's only two real service meshes, like Istio and Linkerd. Ours is Istio. Right? Our GitOps delivery is Argo CD, right? It's just the way that things are packaged and managed together that make consumption of all of them very, very easy on them.
And if you already have a big investment in, say, like Azure Functions or something like that, you can still call it from OpenShift the same way.
Yeah.
So it's, we just give you options if you want to get started in that realm. But if you already have a heavy investment in whatever Azure tool, right, you can just connect it and then use all of that. So
How do you do that? Like, is there some kind of native way to map like a Kubernetes namespace service account to like an Azure AD service principal, or are you putting like static credentials in your applications? Like, is there some kind of mapping there, or like, how does that work?
it depends on if you're like identity or a database, or there's a lot of times there's connectors, right? For like database, if you want to connect to the, I don't know the name of the Azure databases, or Cosmos, or there's a few of them, but
Yes.
yeah, they have connectors. So pretty most of them, and even generic Kubernetes does, right? So they have open source connectors for all those different aspects of tools. Some of them are different. Yeah, but it really depends too, because the networking can get a little complicated, especially when you're in multiple environments or regions. But yeah, there's pretty much every project you can think of, they have some sort of way to connect it throughout, right? Just pure VNets, or call it via DNS or API calls. So
Last slide, and then we'll get to the demo. As we said before, jointly engineered, operated, supported. You get the best of both worlds, and it's fun and easy to implement, right? And it's easy to get started and all those things. So enough slides. I'm tired of the slides.
Quick question on that slide before you leave it. Does that mean you can open a support ticket from either portal, either the Azure portal or a Red Hat portal? I'm just looking at that second row. With
yeah, it should be Azure's level, like they're the first support you'll go through is Microsoft, I think, and because it's a Microsoft, you buy it through Microsoft. And then if they need Red Hat engineering involved, I mean, it's a joint ticketing system, right? So as soon as it comes in on the Azure side, we see it too. But depending on the level of support, right, is depending on who it goes to or what aspect of the product.
Start with Microsoft. That's what I heard.
Yeah.
Does either support team have access to the environment, the customer's environment?
Yes.
I'm pretty sure as a managed service, it does.
Yeah.
Because we're providing like SREs. So, I mean, there's limited access, right? And they'll actually ask you. They'll say like if any sort of elevated permissions they need, they'll say, hey, we need this permission for, or you need to send us the logs where you run the command. And then, but I mean, obviously we don't know, and I'm sure Azure doesn't want to snoop on all your stuff, but yeah, they will ask, so.
Well, and there's good segregation of like database passwords, right? That's a great example, right? Nobody's going to ever ask you for a database password. That's usually that's not what's going wrong, right? Or that's an application log that you can easily see cannot connect to the database, invalid username and password, right? That's usually not the thing. Usually it's like service, principal service agreement, those credentials and things like that, that are, you need to have kind of cube admin, cluster admin type of access to it. Because they will actually do proactive maintenance on it too, right? So if your system is running and something starts going haywire, you don't have to open a ticket for it all the time. Like if the SRE, if it's the tooling is there for the SRE to detect it, they will detect it. It will notify you. They will remediate it, and then they'll notify you when they've remediated what they did to remediate it, if they can do it without your assistance and without any downtime or anything else.
So the platform or custom,
To the platform.
okay, not custom containers. Yeah, okay.
Yeah, it's just platform.
No, they will not. They do not like to touch that. Yeah, that's kind of.
Another question, how about as newer versions of Kubernetes get rolled out, newer versions of ARO come available, what's that upgrade path look like from a customer perspective?
I got a demo for you. Coming up right now. Okay. So the first thing we're going to go to, can everybody see this? Is it big enough?
Maybe zoom just a smidgen.
Okay, so we're going to have a little bit of a cooking show tonight. We already have a cluster that's up and running. It's sitting there, it's ready to go. We'll take a look at that here in a second. We're going to create a cluster real quick though, just to kind of show you how kind of easy it is and what's involved with it. So first of all, I'm going to show you from a GUI standpoint that we're going to use Azure CLI to get this done. But remember, as we were talking about earlier, this is a native service. So you go to all services, and you come down and you say, okay, well, where's my containers? Containers. It's in.
There it is. It's right there. It's right
Oh,
there.
look, it's right there. Boom. Right. So it's right next to everything else. It is a native service. It's consumed the same way. It's charged the same way. It's all the same stuff. So you want a cluster, go in and create a new cluster. Okay. So when you create the new cluster, tell it what resource group that you want it to be put in. You give it a name. You set up the domain name. Okay. And all you need to do is give it some service principal information and a poll secret that you get from Red Hat. And you click go, and it spins up the cluster for you. That's it.
What is the Red Hat pull secret?
That is, it's a piece of JSON that you get from Red Hat. That's your.
It links it to your Red Hat account.
That you purchased Red Hat, basically. You've got to, yeah.
Yeah. Kind of.
But it's all purchased through Microsoft, right? This just links it to your Red Hat account, right?
Okay.
They're joint. Okay. So you can see it, like if you have multiple OpenShift clusters, you can see your ARO and other clusters, right? On-prem or whatever.
I see.
So,
Okay. But that was optional.
yeah, it's optional.
Okay.
Yeah.
Okay.
So that's kind of the easy way to do it. Point click, all those other things. We're going to use the Azure CLI to actually take care of this and do it the one way. I have some secrets and everything set up, so we're gonna just kind of source those as in environment variables. So we have that ready to go. And with that, we'll just kind of we'll do our login as I'm moving around. Please stop me if you have any questions. So we're logged in to our Azure instance. So we're going to export. Our cluster name is going to be Nemo CLI. It's great. So we got to create a network. So that's the first thing that's got to do is you set up the network with a /22. Set it in the resource group. It will we'll come back here in a second. So there's our network kind of container. And in that, you create two subnets. You create one for the control plane nodes. So those are in a Kubernetes environment, there's usually 3 control plane nodes, formerly known as master nodes, but control plane nodes. That's what manages your etcd, that manages all your reconciliation loops, and it runs all of the cluster, base level cluster services, right? So that's the first subnet. And then we need our worker nodes. So we have a different subnet for that. So we're going to create another subnet. within our VNet. So that's where all of our worker nodes are going to sit. And then we'll tie those together with a link here. I'm sorry, we're disabling some of the network policies just to make sure that to be honest with you, I'm sure exactly.
Question?
Is there any architecture design consideration to have the worker node in a different VNet than the control plane?
Typically, no, because you kind of want it like a pool of resources, right? But there are some, and especially in managed services, this is kind of built to just be, you get all the same size, you know, you just kind of work with it all. But there are some scenarios, right? If you have very specific type of machines, if you want to segregate, if they have like some sort of special networking cards or GPUs or things like that, you can segregate worker nodes and label them. So you can label them as this is this type of node. These are segregated for this, you know, project or whatever. That can all be declared. So
We have some customers that run some really, really big risk calculations at the end of the trading day, and they need really, really big machines. But they only want these one processes to use those big machines. So there's these things called taints and tolerations that you can deploy. You can say this deployment only goes on this machine type. And then, so it'll spin up that particular machine type. So you could get the biggest honking VM. You can, it go.
That's what happening at JP Morgan.
Yeah.
I heard that.
So we got all of our network set up. We're good to go. Network. Everything's ready to go. So this is it. We're going to do the ARO create. We're going to tell it our cluster name. We're going to give it the VNet name. We're going to give it some other parameters. The client ID and the client secret is something that's provided to you from your Azure principal. And then we're going to give it the poll secret that's sitting there in that text file. And we're going to add a little debug to it so we can see it go cray. And demo gods be with me. And so this is actually sending the request out to Azure CLI. Azure CLI is going to pick it up, and it's going to spin up everything from the ground up. So it's going to spin up the machines. It's going to lay down the operating systems on all of everything on the control plane nodes. It's going to put all the controlling services that are on there on all the worker nodes. It's going to install Kubelet. It's going to set up all the network policies. It's going to do all of the IP tables configurations. It's all the networking stuff.
Did you describe what operators were as well?
I'm not there yet.
Okay.
I'm almost there. Yes,
It's just the infrastructure, so.
just the infrastructure side. So, so if we look now, we're going to see our outputs in here. Okay, so our Nemo CLI, it's coming up. It's creating. It takes a minute. It actually takes about 25, 30 minutes for it all to kind of come up because it's quite a bit of work. But that's cool because we already have one up and running. So this is the UI for OpenShift. So this is running. This is a separate ARO instance, and what I'm going to do here is I'm just going to bounce around a little bit and go over some of the highlights. If at any point somebody has a question, they want to go deeper on something, they want to get really, really technical about something, you can ask Thomas.
Can we see it in Azure first? Can we see what it looks like in the portal building, Stephen?
Can you show like what infrastructure it has stood up, even on your one that's already up, right? Obviously, we saw you create the VNet. Is it creating like a VM scale set behind the scenes? And if so, do we see that, or is that completely hidden from us?
We should be able to see the VNet, right?
Yeah.
VNet's in there somewhere.
You can see the
The resource.
I think that was two different VNet, right?
There was 2 subnets, 1 VNet. He put the head nodes on one and the worker nodes on the other one. If you were to search for it at the very top, at the top toolbar, type VNet or virtual network.
The other one.
It's the not classic.
That one,
Yeah.
that's it.
There.
There we go.
So there's our VNets. And then I believe it's the compute that it creates is the. It's from the resource group.
Pretty hidden.
Did you put everything in one resource group?
Yeah.
Yeah.
The resource group, you see everything, the component actually.
That's the CLI. Let's look at the other one.
The deployments under the resource group.
Yeah.
Deployments under the resource group, 3C. Yeah. Where it's happened.
How to get to.
You can look at connected devices and it'll show you what's hooked onto that.
Okay.
There we go.
Mm.
Those are all the NICs of the VMs running your stuff and a private link service. I think is for the Red Hat engineers, I think.
But what's the cost delta between AKS and ARO?
So the charge for AKS is just for the compute. It's Linux and that's it, because that's all you get. You get Linux and Kubernetes.
Yeah,
That's it.
there's an additional like sort of subscription fee, but it's like pennies on the. So, I mean, it'll depend on your contract with Microsoft too, and all of that. It can change depending on discounting, but there is like a cluster Red Hat fee for running. It's not substantially more, but there is a fee. Yeah.
So like thinking about like a typical application, you deploy a few applications to an AKS cluster and you've got some load balancers, whatever the compute layer is it, so it's like a marginal increase, but not like double or something?
No, yeah, and it's just on your CPU, right? So it's, we subscribe, like we don't buy it from Microsoft, but we sell based off of CPU usage. So that's where our subscriptions come from. So that's the only thing you'll get charged more for. So, and there's calculators for this. Please verify with me, but every time I've looked at it, it's been like very close.
Yeah, there is. It's in the Azure pricing calculator. You can pick it out, pick the number of nodes. I can show that later if you want.
Yeah, no, I was just more curious, like on like a ballpark, like it's kind of like Oracle. Like if you come from like MySQL or Postgres and you go to Oracle, it's just like this, astonishingly expensive thing. So I was just trying to get like a order of magnitude understanding. And like, I don't need specifics at all. I was just like, yeah, that's.
We're very confident, and I am very confident when you look at the total value of the amount of time that you would take for your organization to cobble together everything that you get out of the box with this. It's very much a steal, right? In terms of the amount of just personnel, just people, right? If you think about even from an individual, like somebody to really, really know Istio. It's not just one person, you have to end up having 2 people to do that. And then if you're a global organization, you need 3 or 4, right? And then maybe 5, right?
Well,
And
don't
then
you
need a
still need
manager for
somebody
that.
who knows Istio though to use it? I mean, like with,
To debug it, yeah.
well, no, I mean, just to like I don't know Istio. And I suspect that if I deployed an ARO cluster, that setting up an application with Istio, I mean, are there like blueprints? Like, how do you get from like me, who doesn't know service mesh much at all, to like, I mean, you still need somebody who knows that, right? Or no?
So this is where we're going to talk about operators. Did you want to talk about that later or?
I was going to talk about operators right now because that's the
Cool.
interesting thing. Okay, and we can go right down that path because it's a great use case. So, I'm sorry, go ahead.
Go ahead.
So here's the thing about OpenShift, right? So an operator is it's a concept, right? But it was actually created and donated by Red Hat back to the Kubernetes community. So the operator concept is based on what they call custom resource definitions. So the Kubernetes YAMLs that you're talking about, the configurations that we're talking about, there are Kubernetes native ones, right? So there's the service, the deployment, the replica set, the pod definition, ingress, all that stuff, right? Those are Kubernetes base type of stuff, right? What the operator framework and custom resource definitions allows you to do is now you can build your own expected YAML and you can build your own behavior that's associated with that YAML. So I can build whatever I want to in a configuration standpoint and then build a controller that can react to it. And so everything from an operator standpoint is kind of this internal reconciliation controller that's running inside of Kubernetes. It's doing the exact same thing. So I can write a custom resource definition that can be like a one-liner that can end up generating 10 different deployments and 15 different services and 14 different routes and attached storage and everything else. Because I have control of the operator, the controller that is doing the reconciliation between the two. So if you understand that concept, all OpenShift is Kubernetes with a whole bunch of operators on top of it. So our big move from OpenShift 3 to OpenShift 4 was everything's an operator and we don't want to do anything that's not Kubernetes. So we donated Kubernetes, we donated operator framework to Kubernetes. It got rolled into Kubernetes, and then we just built everything on top of it. So if you go and look at the cluster operator, everything that we do that provides value on top of Kubernetes is all operator based. So everything that you can think of, from machine configurations, node tuning, monitoring, our marketplace, like all of it's all operators, right? So we're not getting down and doing anything that's different than Kubernetes. It's all Kubernetes. It's all turtles all the way down, right? It's all the same thing. Do you have anything to add to that?
It's sort of like the most advanced way to deploy and manage something. You can just say, hey, deploy this with like a Helm chart or a deployment config or something, right? Which is real simple. It's just say, oh, okay, deploy this. Operators are a step above that, where they have that, you codify whoever it is, whether it be Red Hat or Azure or some database company, can write in the logic for their application to say, this is how we do backups, this is how we handle networking, so that you always have the best practices for your application. And you can essentially, and so like you asked about service mesh, right? Like we have a service mesh operator, right? That just gives you Istio out of the box, where you don't have to mess with, multiple controllers or how you want to handle those specific things. It's sort of, this is best practices, right?
Like the opinionated framework, essentially.
Yes, exactly, right. And so there's a lot of companies that make them, it's a core concept to how we build things. Yeah.
So if you want to, let's say you want to learn OpenShift, and like, is there like a low cost, like, can you run OpenShift on like K3S or some other like free home lab kind of thing, or like, how do you do that?
Yeah, I mean, there's what we call OpenShift Local. You can run it on your laptop. There's free clusters online, right?
Where do you get that?
You just go to try.openshift.com.
Oh, really? That's cool.
Just say, hey, I want a cluster, and then it'll give it to you. You can also do it through Azure, right? If you have free credits or things like that. We have a lot of ways to try it. But yeah.
Cheap in Azure if you shut the thing off, because you pay per hour. It's really cheap.
But and like, here's an example. We're not going to get too crazy with this, but like, so our observability stack is, part of it is Prometheus, right? Well, Prometheus is deployed as an operator.
Could you click on YAML, please, there? Don't mind. Yeah.
So this is a custom resource definition that Prometheus has defined as, this is how you run Prometheus in Kubernetes. So this spec down here is completely made up. Like, Prometheus defined it. They defined what they wanted, and then they built a controller that reads this and does the reconciliation loop to build all those Kubernetes native services that are running. So it's kind of funny, if you look at this thing, you'll see these pods that are running, this is running in a namespace. So if you actually go look at the actual workloads for this namespace, there's the Prometheus things that are running. But there's the Prometheus operator. It's a running process that's sitting there, that's running, that's listening to that custom resource. And that's the reconciliation loop that's running. So it's kind of a reconciliation loop inside of it.
Does it, just out of curiosity, does it matter what those are written in?
It can be Go. The most advanced ones are written in Go, but you can use Ansible and a few. I think there's one other language you can write it in, but most are written or like Helm or something like that. But the most advanced ones are all written in Go.
It just has to meet the API spec. And there is an API spec. So there's an operator SDK that you could build an operator with.
And most consumers of Kubernetes will not do it. I mean, there's really, you would do it if you were like sort of selling software, right? Or you had something that you wanted to deliver that was rather complex, right? Like a database that you were building yourself. But most companies don't build their own operators. So.
And just to clarify, this operator concept, that's OpenShift feature, right?
No, that is a Kubernetes feature. We donated that concept back to Kubernetes.
Yeah, that was 4 or 5 years ago because so many people had so many requests to add to Kubernetes. And we said, well, here's a API spec, write your own. And so now you can say, give me a Prometheus, give me a database, and then the operator will just do it for you, right? It's all in the API. You just define it. So,
We're talking about custom resource
definitions, CRDs. Yeah. Okay. So that defines it. And then you create a custom resource, a CR would actually build it for you.
One thing that I have looked this much into Red Hat's containerization offerings, specifically Podman, that I've been working with, because we are working with a vendor product here, not yours, somebody else's. Then Podman has some neat things in there, which is generate Kubernetes, part of that.
Correct.
And I found that it violated just about every security principle that Kubernetes is supposed to have. Privileged identity, this, that, everything, you name it. It's running as root. I'm saying, what is this? Do you know anything about it?
So
Podman by default will not allow you to run a container. So you have to go in through.
I can guarantee you, if you go to your Podman and say generate Kubernetes deployment, you will say elevated privileges, the whole thing here.
I would love to talk to you about that.
Sure.
Because
I'll show you, because
in my experience.
I'm looking at that, I'm saying, what is this?
By default, our OpenShift instances, by default, have always been, from a security context standpoint, you have to explicitly say, I want to run something as root. Because at least from an OpenShift standpoint and from a Podman, by default, you cannot run something as root.
I'm talking about privileged access.
Privileged access, yeah.
Yes.
You have to specifically configure that. So maybe it's generating a configuration that sets that up or something like that, but we can talk about it all.
Okay.
yeah, if you write your container to run as privileged, it'll generate that YAML for you. But OpenShift with our security policies will not allow it because it's not a standard way you should run containers. There are some containers that need to run privileged, but most applications don't need it. So by default, they're blocked. You can set those security policies depending on the app, but it's really to prevent people from doing bad security practices. But Podman's also sort of like an open source project. So where it's not the platform that OpenShift is. So if you tell it generate YAML, it'll generate YAML for you. It may not be OpenShift compliant, but it is YAML for you.
Do you have some best practices baked into your product?
Absolutely. But you're talking about Podman or OpenShift? Both. OpenShift has the majority of them. Like every container service, like we just talked about, will allow you to run as privileged, which is bad because if your container can essentially escalate to the host potentially if you have problems. So the goal is you want to run unprivileged ports, unprivileged users, you want to use, standard security practices for containers. We kind of invented this. We actually created what's called SEC's security context constraints. And there's a massive list of them, right? But it'll define like, do I have host level access to file system? So does your pod need, most pods do not need access to the file system, right? And so there's definitions of what we have. The first one, which runs for everything, is restricted. So it restricts all that, restricts, elevated network access. It just, all of those are essentially removed by default to prevent people from doing bad things. When
In
they go
OpenShift.
Yeah, in OpenShift, right? But pretty much every other Kubernetes will allow you some sort of elevated privileges. We invented the SEC, and which is now becoming the pod security. What's it?
Our security policy is gone.
Yeah, it's gone, but it's now pod security admission is the new one. And so, like Kubernetes didn't even know how to figure this out, right? They created one and then it got deprecated because it didn't work for them.
I'm sorry, I didn't mean to derail.
No, it's a good topic from a security standpoint, and it's really just to prevent people from, stepping on their own feet. So.
We are big on security. Like, we're a Linux company at our heart. So when it comes down to security, it's something that we take very seriously.
Yeah, speaking of security, if it did have to reach out into like blob storage, would it use private link? Do you use all the private endpoints, or are you going over the internet?
I know the answer to that.
Okay.
So that you can configure, if you configure the Azure service that you want it to read from, like blob storage, for example, you would need to configure private link to the VNet where your ARO cluster is. And then it will resolve the private link of the storage account and use that. If you don't do that, then it's going to try and go out to the internet and hit the front end of the storage account. So by default, it doesn't have that. But of course, you should. That's your question.
Should you make separate subnets for each type of resource, like a storage subnet or?
So you can, that's usual best practice. Yeah, you'd have a subnet, not necessarily for a type of resource, but a subnet for private link. So a private link subnet off of where your cluster VNet is, and then whatever you're trying to talk to, your storage account, your Cosmos, SQL, whatever it is, just join them all to that, and the cluster will just use those. Best practice.
Time check. I just want to make sure we have a couple other things that I would definitely want to cover before, but we can go for as long as anybody wants to stay. So to answer your question about upgrades, this is my favorite thing about OpenShift, right? This is the thing that's kind of wowing. So OpenShift runs everything from the OS up, right? So the operating system is CoreOS. Well, it's called RHEL CoreOS now. It was an acquisition that we made of CoreOS a couple of years ago. We integrated it in. It is an immutable operating system, right? With the bare minimum tuning that's only configured to run containers and pods. That's it, right? So we strip out all the other attack vectors. We make it very, very slim. And so that's what's running underneath it, right? That's what's running as the base OS for all of the worker nodes and the master nodes. When I do an update, I'm doing an update of everything. So what it does is it'll mark each one as like the worker nodes. It'll mark it as unschedulable. It will stop scheduling stuff out there. It will then start killing those pods, and then we'll move to the other worker nodes. It will make sure it's empty, and then it'll kill the VM, and then it'll create another VM with the updated operating system, with all of the patches, all the CVEs are all taken care of. And then it will do the installation. It will reattach to the cluster. It will mark it as schedulable, and then the pods will rebalance. How it does that is by clicking a button. You can also schedule it. You can also kind of do partial updates. The other thing that's cool about this is our SRE teams will nudge you along because we want you to, especially if you're staying on a minor version. So like I'm on 4.10.40. They basically come out with a patch minor version release almost weekly because it's covering a bunch of CVEs across the entire stack. So, and it's covering everything that's included with it, right? But the neat thing about this is each one of these, see how it says recommended, right? I can jump to any one of these versions, and that's part of the value that Red Hat brings to this, is we go through and we cycle through testing, upgrading from this version to this version, this version to this version, this version to this version, with all of the different things loaded into it, right? With service mesh and GitOps and all the other stuff. And we make sure in thousands and thousands of tests that we make sure that your upgrade path is going to be smooth. So for any of these things, we'll do this at the very end, and I'll show you. It'll start kicking off, and we'll go through all the different. That's one of the neatest things. You can also kind of run this during the day if you want to. Like, it doesn't have to be, like, I recommend to do it on your off time, of course. But it's not, there's nothing that stops the world, right? Because it's only killing one pod or killing one node at a time. You might see some maybe service small, like maybe if you're doing something that's super scaly or something like that. I don't recommend to do it at the heat of the day, right? But it can be done.
Steve, good question. The existing pods, Steve?
Yes.
Yeah, so existing pods that have vulnerabilities, when you do these updates, is there a way to establish some policies or quarantine them?
If there are, if there's CVEs that are associated, that's usually what's covered in our cluster operators. So that's, we cover all those CVEs with our update as it's coming in. We have a separate tool. We have a separate product called ACS, Advanced Cluster Security. I almost forgot it. It's our StackRox acquisition that is a bolt-on to OpenShift or runs in OpenShift, and it has every security feature you could think of. I sat through a demo of it today for one of our customers, and it is not only CV scanning at runtime, but it will give you a laundry list of best practices and even customized policies that you set up to give your operation team feedback of what's going on in your cluster from a vulnerability standpoint.
At a platform level, the upgrades will handle CVEs, right? So when you hit upgrade in the OpenShift console, that handles the platform, because everything's a container that runs the platform. What he just mentioned, ACS will handle your application, right? So if your applications have vulnerabilities, it can do that for you.
We're going to go over here. We're going to do a little guided quick start real quick. So this is kind of the fun things. So we're going to let's do some operator stuff first, because it seems to be some things around that, and then we'll deploy to happen. So let's talk about, do you want to do pipelines or serverless?
Serverless.
Serverless.
It's cool.
Okay. So if we want to install the serverless capabilities, right, it's Knative, right? So we want to install that. It's real quick. So we find the serverless operator. So we can go to Operator Hub over here, right? And Operator Hub actually has all of the operators that are certified to be able to run on OpenShift. So there's a bunch of, so you can come down here and you can filter out like who's the provider. For operators, there's a place called Operator Hub that is the global marketplace for operators. Out of those operators, there's also OpenShift certified operators. So those are operator providers that have worked with us to validate, hey, this runs on OpenShift and it runs really well on OpenShift. So when you start looking at different products, I'm going to take out the serverless just for a second, but like, here's all the databases that you can run as an operator on OpenShift, and I'll filter out the certified. Right, so all of these are certified. So there's support that you can get from them, and they have been tested and certified by Red Hat to run on OpenShift. And there's all kinds of other stuff. So there's all the networking tools, so you can swap out your networking. You could do security pack, security different things. So ACS is one of those, but if you want to use a different one, you can. There's a lot to unpack here from the ecosystem standpoint, everybody providing their operator to do the thing. So we're going to do the serverless operator. So there's our Red Hat OpenShift serverless. So it's an operator, runs on OpenShift. Support for this is included in OpenShift, right? So you don't have to buy anything else. You want to run Knative, boom, here it is. So we're going to do the click install. It gives you all the recommendations. So it tells you what update channel you want to use. So it'll actually go through and do updates if you wanted to. Your installation mode, this particular operator says I'm going to install on to where all the namespaces on the cluster can use it. Some operators can actually narrow the scope and say, I only want to run anything that's operator based in a particular namespace. So you kind of segregate and keep things small. This is going to create a namespace for us. That's easy. And then we want to have the updates happen automatically. You can also set those to manual too and do the scheduling for updates there as you want. It's going to install the operator. What this is actually doing is kind of doing two things. So it's going out to Operator Hub and it's going to go get the actual image that is the operator runtime. That's the container itself, and that's run as a pod, right? So that's going to be running. And it's also going to take all of the custom resource definitions that are defined along with that operator, and it's installing that as cluster resources. So I showed you the custom resource definitions earlier on things. After we get done here, we'll be able to go down and see the CRDs, and the serverless ones will now be in there alongside all of our other CRDs. Just like everything.
Good question.
Yeah.
Adding in these operators, that would be, you know, the admin's job, not the developer, right?
Yes.
Is there a case where a developer will say, hey, admin, I need that one operator, or is that not a thing?
By default, they can't, developers can't install operators. I mean, you could give them specific permissions to specific ones, right? But by default, it's kind of built to be, here's the access that we want to give you to, you know, least amount possible, but you can also enable that. All of this is RBAC, you know, role-based access control. So
let me ask that a different way, and it's because I don't understand operators as well as you guys. Are there certain operators that enable a developer to do something that they wouldn't be able to do otherwise? Like, hey, I want to use a MySQL database, please install that operator? Or is that, am I completely wrong?
No, that's exactly it. So like, let's go back to the administrator real quick. We're going to go to this operator hub, and we're going to download my favorite. Create a new one. We're going to install it. And so when we install this operator, that will give capabilities in the developer view. So what we're looking at is the administrator view. So I have to be a cluster admin to see this. If I'm just a developer, this is the other view that I see, that it's not the other thing. Well, when I go in here and when I say I want to add something, this gives me the ability to come in and say, I want to add something, but I want to add something that's operator backed. If I click on operator backed, it's going to tell me all of the things that I can do based on what my cluster admin gave me permission to do based on the operators. So one of the great examples of this is Kafka, right? Anybody run Kafka?
Not personally. I don't touch that.
It's a beast, but as an operator, it's easy because all of the different things that you need to set up and all the bindings and everything, like it's the operator manages it all for you. You just say, give me a cluster with 3 nodes, boom, go, and it sets everything up for you and does all the networking. As a developer, I can go in, if I have that operator, I can create a custom resource that says, give me a Kafka topic in this cluster, and it'll make it for me. I don't have to go through and do all the Kafka CLI. Extra bonus points is I can take that custom manifest now, I can store that in my GitOps repo, and I can recreate these environments from the manifests. So like all of my setup for all of my middleware and everything else, I can put it into source code. It's
So
really
think of it,
powerful.
think of an operator as back in the day when you data center days when the developers needed something, they'd open a ticket and would go to operations team and they would do it, right? So this is codifying that into your application.
Right, but like on ADO, the developer would see the marketplace and hit request, and then the admin would have to complete that. Does the developer even see this operator hub?
No,
They don't know it's even available? Yeah.
And just to beat a dead horse, just to make sure I understand this, does the developer instantiate an instance of that operator? So
No,
you,
the
no?
operator's running,
Okay,
the developer
just uses it.
uses it.
Consumes it, yeah.
They would call it essentially through their deployment YAML.
Correct.
Through a GUI API call or the CLI. Yeah.
So here's if I want to create a new Cockroach DDB cluster, this is their custom resource definition. So when I create this as a developer, it's writing in my namespace. The operator is doing the things that I want it to do, but I'm not in control of it. The only thing I'm in
But you
control.
are instantiating something then, right?
Yes.
Okay. That makes sense.
So do the operators ever include any inherent authorizations?
Depends on the operator implementation.
Do you ever get objections with like either financial services companies or like large, like Exxon, for instance, to having to put like static service principal secret IDs in the configurations? Like when we stood up the cluster, the ARO thing initially, like it was a static secret. Or like when you're, like if you're doing the Knative serverless thing, like how do you authorize your serverless function to talk to, say, some Azure service? Do you have to put a static service principal in there, or is there like a mapping where the Kubernetes identity that it's running under will like automatically get permissions to talk to, like, say, blob storage based on like an Azure policy or some kind of like IAM mapping? You know what I'm talking about?
Yep. There's a couple different ways you can do it. Typically, I'd use a secrets manager of some sort. So HashiCorp Vault, right, is the kind of the one. I think Azure has a native one.
Key Vault.
Yeah, Key Vault or whatever. If there is, I think there's is there a Key Vault operator?
There is a Key Vault operator there is a Key Vault operator.
But I've seen people put static service principals in Key Vault, which kind of confused me also. But like, so like with Kubernetes, and this is kind of like really at the edge of my understanding, but a Kubernetes service account will have a JWT, like a JWT token, and it can use that to talk to other services. And if the service is configured to trust the Kubernetes cluster's CA certificate, that's like the foundation of the identity. So you don't have to like put static secrets anywhere, and it's all dynamic. Like,
Yeah, if it's just OIDC based and it follows the OIDC spec.
so does that work the same thing with an OpenShift, kind of like the same way that it does with just regular old Kubernetes? Like if that whole like layer, I guess.
You're talking about authorization.
Mhm.
So there's an OAuth server built in to OpenShift that'll basically, this is also one of the great things about operators here is you don't have to build that authorization into your application, right? So if you just want to authenticate, you will essentially log in with, you'll set up your authentication to start with, right? So whatever it is, Active Directory or GitHub or whatever. And then that maps to an identity in OpenShift. And then you can use that identity to do all the OpenShifty things with operators. And so you don't have to build identity for your databases, for your service mesh, for your whatever. It all comes as like that service account, right? It's essentially like a pass through.
Cool.
I don't know if that makes sense. I'm also not an identity expert, so.
I'm like an identity expert. Like that's hard. Like, because every organization seems to do something a little bit different. It's just different enough to make it hard. But our back from a JWT perspective is like, are the roles on it? And do I have the public key to verify that it wasn't tampered with? And then it's up to the application.
Is there any indication looking at this portal that we're even in Azure?
URL.
That's a good call, actually. It took me a while. So this is actually running on the head nodes of his cluster, right? This whole portal delivered off of your
No,
actual cluster,
it runs the console and all
this.
yeah, the control plane nodes essentially run the API and then the database.
Okay.
That's it.
So I thought this was, okay, this is
a
running on
pod
the
that's
worker
running on
nodes.
worker nodes,
Yeah.
It's on the worker nodes. Okay. Yeah, it's running on the worker nodes of the cluster.
So,
AKS does not do this.
so let's talk about that real quick.
Yeah.
So let's talk about.
This is an open shift feature, right? This whole portal.
Yes.
Yeah.
So we're talking about the compute.
So ignore all the subdivisions.
Okay, so there's our machine sets. So this is the way we've defined our machines. Go look at the machine set. If you look at a machine set is an abstraction, so it doesn't matter. But when you get down here to the actual spec, that's when it starts to get in, and it's like, there's our managed disk specifications, there's our user services, there's our whatever. Where's the your machine? Oh yeah, so there's my VM size, right? So you can go through and create. That's the only difference.
A question for Adam. Do you know if this is a VM scale set on the back end, or is Red Hat doing their own orchestration?
I'm pretty sure it's not. So we do our own. Essentially, we have what we call machine sets. I mean, you can go look in the portal to check for scale sets, but it's all configured essentially from the OpenShift side, because you'll define your machine type, your number of instances, and then all the auto scaling is done by OpenShift. It holds there's like a credential operator that'll manage your credential to Azure, and then it'll say, hey, Azure, give me this VM to scale.
Just
So is that-
separate VMs. Sorry, go ahead, John.
Yeah, so is it like an owner role service principal that it takes then to do the initial setup?
I'm not sure.
I mean, it sounds like it has to do a lot of really privileged things.
It does. So when you instantiate it, there's a big long list of permissions you need, right? You need quota, you need CPU, you need access to all these things just to build a cluster, right? But you can restrict those afterwards as well, depending on what you want to restrict. But if you go look, I mean, all this code is on GitHub. You can go look at exactly all the permissions that it needs to start, and then there's documentation around how you can restrict it too.
So we are getting to where it's 7:30. So before we start to walk out the door to anything else, I want to thank everybody for having us. It was fun. We will stick around and answer any questions that you have or anything else. And of course, reach out to us if you need any help with ARO.
Okay.
If anyone has additional questions around that pricing that you asked, I've got a calculator up, so I can kind of walk through.
Oh, yeah, thanks.
I actually have some bonus content.
Actual sales. Solution architects is like price. This costs money.
Yeah.
I've got some bonus content just for funsies, but you guys may not know this. So one of the things that
Sure.
I will in a second. I was going to call out Brad's question about the URL that's running on the pod here. So that's an internet facing URL. And so, best practice, right, wouldn't be to have that. But it's much easier to stand up the ARO cluster using the command line that Stephen was showing. But if you're going to do it like for realsies, then you would have that private, have all the storage private, use the private link you were asking about. And that's a lot more work. And so that makes a terrible demo, but it is how.
You can't see anything.
Yeah, it takes too long and means that it's hard to see and use and all that. But it is what we recommend customers to do. So to make it easier, I'll share. I'll take over now. I'll share real quick. Microsoft has actually created a. Let's see.
Do I need to stop?
I think I can. Microsoft has created these handy dandy infrastructure as code solutions for enterprise customers out of GitHub to deploy ARO sort of like air quote, the right way. So this is how we recommend enterprise customers who are going to do it for real should do this. Same product, same everything, but with a whole bunch of extra guidance, including, for example, not having the public-facing endpoint for that beautiful portal that Stephen was just showing. And then also as part of, ordinarily it wouldn't be on a VNet, of course, by itself. It would have connectivity by ExpressRoute and on-prem and all of the usual enterprise things that enterprise customers would have. Again, no point in having that in a demo.
I got a better picture than you.
You got a better one on this one?
Yep.
Okay. Well, good. This is the one we use to sort of show what this accelerator does. And then we have a baseline.
Yeah, I took over.
Oh.
Sorry.
Oh, yeah. I didn't know. Okay. You have
This one.
oh, yeah, there we go. Yep, like that. Like that. But what we have on the GitHub is infrastructure as code to deploy that. Yes. just
To
like
do, it does all of this stuff?
that. Yes, it does.
Very cool.
Yeah, that pattern. Yeah, app gateway, standard bastion, put private link service in there, Azure Container Registry, and there on the left there is exactly what you were asking about, Brad. So there's all the private links, right, from Key Vault to Cosmos to whatever else you've got in a sublink. Chuck them all in there. That's right. Yeah. So this is how you should do it. A lot more work. Shouldn't do it by the portal, of course. And so we have an accelerator that's in Terraform for you cross-cloud folks, or people who just like Terraform. Bicep, if you're like Bicep, which is Microsoft's own version of infrastructure as code. Ansible, or just good old-fashioned Azure CLI. So out on GitHub, FYI. All use that. Yeah.
You mentioned,
Still your presentation.
Oh, that's fine. I just, yeah, that is a better picture than the one on the GitHub. Yep. Okay, that was my bonus content.
going way back to ACS, what repository do you use for the images? Is it ACR or like an OpenShift repository?
Yes. Well, like for the Red Hat stuff, we have our own registry. We have a service called Quay that is our own registry. We keep all of our stuff out there. But for application registry, yes, you can use whatever you want.
And does
OpenShift come with one?
It comes with one internally, yes.
Yeah, you don't use it for storing. It only basically it's like a cache, right?
Oh, okay.
Because it's just a very basic registry, right?
Okay.
We have Quay as our like
The real one.
mainstream real registry where you can
Okay.
store art, like, OCI based artifacts and things
Right,
like that,
right.
but Helm charts.
Right. So that's internet facing, like Docker's one or GitHub's.
Well, or you can do private, but
Okay.
it's kind of like a separate thing.
Okay.
And does it scan for vulnerabilities while it's an image or only when it's running as a container?
ACS? Yes.
ACS will do.
Yeah, it does runtime scanning. It does, you can call it in your build CI/CD processes, so you can break builds. You can run it as a CLI on developer desktop, so they don't have to wait for the build to do their scanning. And, so all of it.
It supports Windows containers or no?
Yes,
It does.
we support Windows containers.
What's the split between like of the install base between like private data centers versus public clouds?
I don't know. I don't think I've ever personally seen that at Red Hat. So I don't think they disclose that to us.
I don't, yeah, that's
Because it's enterprise.
Yeah.
big number. I don't know.
I'm just wondering like if it's primarily, 'cause it seems to me like it's historically been like mainly like a private data center thing.
OpenShift or?
OpenShift, wasn't it? No, OpenShift in general.
When it started, yeah, absolutely, right? Because they didn't have managed Kubernetes services. But now it's just, people go back and forth. There's a lot, most of our new installs are cloud-based. So, the majority of them are cloud-based now. So, and these managed services like ARO, most of them are that now.
It really depends where they were on, the customer was on their container journey, right? Some are just now kind of entering that. And then others started early and had some on-premise applications or some either custom or off the shelf that they needed to run for data privacy, data security issues on-prem. So we'll see, this is kind of why Red Hat, we talk about this being the hybrid strategy, right? Because ultimately it doesn't matter if it's on-prem or in the cloud, but we're seeing our growth right now, it's all cloud-based.
We do have a good bit of growth on the edge too. So people that want to run Kubernetes and smaller based devices farther out from their data centers, we do have a good bit of requests for that too. So.
Want to mention Cluster Manager maybe? That would be a good time to talk about that.
I don't have any demo for that.
Yeah, no.
We have an additional product. So we have a full suite called OpenShift Platform Plus, great marketing name, right? OPP. It has this other thing called Advanced Cluster Manager. And you think about that as the manager of all of your clusters. So you hook it into, and so you can manage your applications at like a global level. So like, let's say you're running OpenShift in like 3 different regions or something like that. If I want to roll out a new application version, I can do it from ACM and it will automatically set
There
everything.
can be different clouds on-prem, it sees all of it.
It even works with EKS, AKS, so it works with Kubernetes. So that's pretty neat. The really neat thing about it is policies, is security policies and things like that. When a 0-day comes in or some oopsie comes in, you can quickly get that policy, put it into ACM, and have it distributed out to all of your clusters instantly, relatively instantly.
You can also do multi-cluster networking. So you can create IPsec tunnels between 2 clusters and call the service from cluster 1 and cluster 2. And now you don't have to do all this complicated, it's east-west traffic essentially at that point, right? It's all over private networks versus going out.
So like doing that with Istio or something else?
It's called Submariner is the project, but it's integrated into our ACM product. Yeah.
Oh, by the way, our other cluster that we ordered is in.
Finally came up.
Quicker if you pick bigger VMs.
Yes.
Those VMs were very affordable. Spend more money on VMs, Steve. It'll come up much more quickly.
Yeah, and all of our metric dashboards, like this is kind of neat because it's all Prometheus, Grafana. So like you can build your own custom dashboards with Grafana, upload them in. You can build all of your own Prometheus alerting metrics and put all that stuff in there. It's all ubiquitous CNCF huge projects. So you're not learning. So you're learning some very transferable skills. Let's put it that way.
This is like a huge value add over like AKS, which doesn't have this baked in.
1 billion ARR, right? There's a reason that people buy this, and this just makes everybody's life easy.
Right.
It also stops. It's really funny because it stops some of the bike shedding, right?
Bike shedding.
Arguing about pedantic things that don't really matter to the business, like service mesh. Should you use Istio or Linkerd?
OSM.
Yeah, but like but what kind of monitoring frame? Have you ever seen? We have a slide that's all the CNCF, all the projects or whatever. We use it as an eye chart, kind of in the middle of the thing, because the big problem nowadays isn't necessarily the technology; it's the myriad of options and the analysis paralysis that companies get into. Of I have 15 different ways to do this. How do I do this? We bring a lot of opinionated nature to our, this product that eliminates a lot of I like this, and it's subjective. It's completely subjective.
Too many
right?
choices.
Yeah, it's too many choices. So this kind of knocks out a lot of that.
You can still use whatever you want. This is a fully, Kubernetes compliant API, right? You can still do whatever you want with it, but we give you options of supported ways of doing things.
Like
You
our
can call us
logins,
for, and Microsoft.
like our logins elk stack, right? So, but if you have Splunk, cool, just forward the logs out.
Or to Microsoft's
Yeah,
add logging
as your
credits.
monitor,
Yeah, you
Or
can
actual
store it, yeah,
as your monitor, which has log analytics something.
yeah.
Okay, any more hard questions for the Red Hat guys before we?
One more.
Okay, go for Brad.
Customer deployments, is it only through rolling updates or can you do Canary?
You talking about update to the platform or,
When I want to update my service, I have version 2,
oh,
and I
yeah,
want to split like maybe 10% of the traffic out into my. Oh,
Yes.
that's bad.
Yeah. No. It's service mesh, right? So.
application.
Yeah, the application containers.
Yeah, if
My
you want to do
stuff.
that with service mesh, you can do that with service mesh. You can actually set it up and say, I want to divert traffic. I want to say 10% over here. I want to do blue-green.
you can even do that with routes.
You can't do that with
Yeah,
routes?
you can do that. You can do
Yes.
percentage-based load, and you can also do, switch, say, hey, go from A to B. You just change the name, right? It's all DNS-based, so you just go change your route from here to here.
With DNS.
Yeah.
Point the route to a different service.
Yeah, that's all you do. Just change your service name and you're done. Or you say 50-50 this way, or 10-20, 30, whatever.
Thanks.
I got a question. When you're doing an update of either Kubernetes or OpenShift, and it's running, what happens? Do you have to shut it down in order to do the updates?
No, it will move all the pods from the node that is updating.
Let's update.
Yeah, and then,
Gotcha. You'll see the cluster operators will start. So this isn't, so the funny thing is the update process, it's an operator too. So, where's the operator?
it's a cluster version or something like that.
Yeah,
It starts with
cluster.
a U.
So what about if you have to upgrade underlying Kubernetes?
It does that for you. It upgrades the operating system, it upgrades Kubernetes, and then all the components around it, DNS, your SDN, your every piece of it gets upgraded all at the same time. So it's a package of content. So if you actually want to go look at what the updates are, it's just a list of container images. Just goes in.
I got GUI as well. Nice.
Yeah, that's one of the other things that I didn't really highlight very well on the developer GUI. We'll come back to that other thing, but this is really kind of neat from a topology standpoint. It's like you can go to each one of your namespaces and you can click on the thing and you can see the running pod and you can go and see the logs instantly. Like that is so slick. Like get out of the CLI.
Like the container logs?
Yeah, these are container logs.
That's cool.
Oh, you want to go into the terminal? Cool. I'm in the terminal.
And it generates so much YAML for you, right? If you just like, I don't know these, I just want to build a database, right? You just go, and then you can put it in your infrastructure as code, right? Like that. It's just it's a quicker way to develop, right? Because we can just generate all that code for you and then you can just put it in there.
How much more compute and memory does it require to run OpenShift over like a more vanilla Kubernetes?
There are some, like, there's a bunch of, because we have all these operators and then that manage the platform, there is more, right? You're going to need more compute for it. I think the minimum for control plane is like 4 cores, 16 gigs of RAM. Workers is like 2 cores, 8 gigs of RAM minimum. But yeah.
But that's actually the same as AKS's minimum is actually about exactly the same. I mean, needs some horsepower for all that stuff.
Yeah, that's for high availability, right? That's where you get all the, if you lose a pod or a node, you're good. But you can run K3S or smaller things that don't have high availability built into them. So if you just want single node or smaller things like that, so.
I have 3 Intel NUCs at my house that I run a 3-node cluster on, and it runs fantastic. Cool. And I use an automated installer that's like USB driven. I downloaded an ISO, I burn a USB. I walk up to all the boxes, I plug it in, I turn it on. It registers out to the console.redhat.com, checks in, registers it. And then I do it on the other 2, and then it goes and installs everything. It actually bootstraps Kubernetes to install OpenShift. I don't understand all of that stuff, but it's fun.
Oh, and that's the core OS on the bottom. So it's almost like a type 1, type 2 hypervisor thing. It kind of feels analogous to that a little bit.
A little bit, yeah. For the install process, and then after that, it's just core OS.
That's pretty cool.
All right. Okay. Thanks so much, guys. Really appreciate it. Thank you everyone online. Take some pizza.
Thank you.